Hey, welcome back guys, and in this video we're going to be taking a look at how to make a line type of tool with ARKit. And basically what this is you're going to move your camera around, as you can see in the video happening right now. Actually, I'm not going to put the video in right now. We're going to see what's going to happen at the end. But what we're going to do is when we're moving our phone around, we're going to have a little string that's going to be following us, and it's going to be wrapping around the object we follow. So we're going to be doing that, and we're going to be creating one class that's going to be used for our next project as well. It's a quick project, it's a quick class, and we can start off by selecting a new file. Let's go ahead and select a new file, and then we're going to call this scn vector3 extensions. And okay, so what we're going to import here besides foundation is scene_kit, and now we're going to make an extension. So we're going to make an extension called scn vector3. We're just extending on scn vector3, so we're going to be able to make the string attached, and this is also going to help us for our next project where we're going to be able to paint in the AR world. So this is going to be quick and simple. There's not much to do here. Alright, but our first function here, this function is basically going to negate the vector that's described by the scn vector, and it's going to return the result at the new scn vector. So we're going to call this function negate, and it's going to return scn vector3, and we have our open curly brackets. And what we're going to do is we're going to return self times -1. So basically what we're doing is we're just returning our new scn vector3. So it just puts it into a negative. So okay, don't mind the error right now, it'll automatically fix by itself. So we have our function negate, and it's returning scn vector3. Don't worry about this error, it'll automatically fix by itself. And our next function is we're going to negate the vector that's described by the scn vector3. So what we're going to do here is we're going to type in mutating the Swift keyword. So if you don't know what this is, you can watch my Swift 4 whole guidance thing. Like, I teach you guys how to go from ground up from Swift 4 and create new awesome apps. So we're going to go mutating function negated, and we're going to return scn vector3, and we're going to have an open curly bracket, and then we're going to do self is equal to negate, which is our function that we just created above, and we're going to return self. And okay, and one more tip, so if you guys do not understand what mutating and stuff means, what you could do in Xcode 9 is that you can actually click option on the whole function, like your option key, and click it onto the whole function. So you could click it on negated, and you figure out what type of function this is. You could figure out what scn vector3 is. It's a struct, and then you could even type it on the whole function, tap it on the whole function, and you'll see what mutating is. And then you can tap on it, and then it tells you where it's declared, and you can learn a lot about more classes like that. But anyway, let's create our next function. This next function is basically going to return the length or the magnitude of the vector described by the scn vector3. So we're going to name this function length, and it's going to return a type float and open curly bracket. And what we're going to do is return sqrtf, and it's going to be returning a float. So we're going to do x times x plus y times y plus z times z. Alright, and now we're going to go down again, and we're going to create a new function called normalized. And what this is it's basically normalizing the vector described by the scn vector3 to the length 1.0, and it returns the result as a new scn vector3. So let's go ahead and create this new function called normalized, function normalized, and this is going to return scn vector3, and we're going to have an open bracket, and we're going to return self divided by length, and yes, and then now we're going to create a new function again. This one is going to normalize the vector described on the scn vector3 to length 1.0. So it's not, this one would do the exact same thing, but this one also returned the result as a new scn vector3. But this time we're not going to be returning a new scn vector3. We're actually basically converting it into the new length. So this function is going to be called mutating function normalize, and we're going to return scn vector3, and we're going to have our open curly brackets, and we're going to have self is equal to normalized, And what we're going to add here is we're going to return self. So we just basically called this function and we're returning self. And it cannot be called here yet. Don't worry about this. We're going to be able to fix this in just a few, but don't trip about this just now. And now we're going to create another function again. And this function is basically going to calculate the distance between two SCN vector 3 and using the Pythagoras basically. So this function will be called distance, and it's going to take in the parameters of vector, which is a type of SCN vector 3, and it's going to return float. So we'll open a curly bracket again, and in here we're going to return in parentheses self minus vector and then dot length. That's what we're returning. And then we're going to create a new function which is going to calculate the dot product between the two SCN vector 3s. So we're going to call this function dot, and it's going to take the parameters vector as a type SCN vector 3, and it's going to return float, and we're going to have open curly brackets again, and inside this we're going to return x times vector dot x plus y dot plus y times vector dot y plus z times vector dot z, as you guessed. And okay, so now we're going to create a new function called calculates the cross product between the two SCN vector 3s. So another function. So this whole extension is basically just creating tons of functions. Don't worry about these errors yet. These will get fixed on in future videos as I show you when we build on to our project. These errors have just not been declared and stuff yet, and they're going to link in perfectly, and then don't worry about that. So it'll all play out in the end, and I'll explain it to you fully once we declare those stuff. We'll come back, we'll revisit this, and we'll explain it. So let's go ahead and create the new function, which is going to calculate the cross product between the two SCN vector 3s, and we'll name this function cross, and it's going to take in the parameter vector for SCN vector 3, and it's going to return SCN vector 3, and we're going to have an open curly bracket, and what we're going to return is return SCN vector 3 make, and we're going to return all these floats, so x, y, and z, and we could just do y times for vector dot z. Y dot vector, y times vector dot z minus z times vector dot y. And then for y, we're also going to have z times vector dot x minus vector minus x times vector dot z. And then we're going to have for z, we're going to put x times vector dot y minus y times vector dot x. And okay, so that's just calculating the cross product between the two SCN vectors. This is going to calculate the dot product between the two SCN vectors, and this is just calculating the distance between the two SCN vectors using Pythagoras. Don't worry about these errors. As I said, we're going to get back to it. Let's go ahead and create our new function again outside of this, and this is going to be outside of our extension. So this is going to be outside of our extension. So this function, what this function is going to do is we're going to add two SCN vector 3 vectors, and what we're going to do with this is we're going to return the result as a new SCN vector 3. So we're going to create this function func plus, and taking the parameters left be a type of SCN vector 3 and right as SCN vector 3, and we're going to return SCN vector 3, and we're going to have open curly brackets. Okay, and we're going to return SCN vector 3 make x, y, and z, and we're going to, for x, we're going to put left dot x plus right dot x, and for y, we're going to do left dot y plus right dot y. Let's continue. Let's just write this down, right dot y, and then for z, we're also going to do the exact same thing, but with z. So left dot z plus right dot z. Okay, and now we're going to create a new function Now we're going to create a new function which is going to increment the SCN vector 3 with a value of another. So let's go ahead and go function plus minus plus equal. So it's just adding incrementing it. And then so if you don't know what this is, you can watch my Swift 4 course again. So this is just incrementing the thing. So left is going to be as in out scn vector 3, and right is going to be of type scn vector 3. And we're going to have our open curly brackets, and we're going to set left is equal to left plus right. And now we're going to create another function. Yes, another function. This extension is based all off functions. That's all we're doing in here, and we're almost done, so don't worry. It's just a couple more functions left, and there's nothing too complicated right now, so don't worry about that. So now this function is basically going to subtract two scn vector 3 vectors, and it's going to return the result as a new scn vector 3. So let's go ahead and create this function. Minus left as type scn vector 3 and right as also type scn vector 3, and it's going to return of type scn vector 3, and we're going to have open curly brackets, and then inside this we're going to return scn vector 3 make, and then we're going to have left dot x minus right dot x, and then we're also going to put that for y and z. So left dot y minus right dot y, z is left dot y minus right dot y. Okay, and now we're going to create a new function which is going to decrement scn vector 3 with the value of another. So this is incrementing plus equal, and decrementing is going to be minus equal, and this is also going to be taking the parameter left, and then it's going to be in out scn vector 3, and then right is also going to be scn vector 3. It's going to be of type scn vector 3. We're not going to return anything, we're just going to have open curly brackets, and then we're going to do left is equal to left minus right. And now we're going to create another function which is going to multiply the two scn vectors, and it's going to return the same result as a new scn vector. So let's go ahead and create test. So it's going to be function multiplication sign left of type scn vector 3 and right of type scn vector 3, and then we're going to open the curly brackets, and it's going to be type scn vector 3. We'll open this up, and inside this we're going to return scn vector 3 make, which is going to be x, y, and z. X is going to be left dot x times right dot x, and then left dot y times right dot y, and then left dot z times right dot z. And I guess you guys can see the pattern where this is going. We're just going to go plus increment minus increment times, and we're also going to increment that. We're basically going to multiply it with each other. That's going to be our next function actually. So let's go ahead and create that, where we're going to multiply them with each other. So it's going to be times equals, and this is going to be left in out scn vector 3, left in out scn vector 3, and we're going to have right type we're supposed to put this right here in the column, that's why it wasn't autofilling, but we're going to go scn vector 3 again. We're not going to return anything, just remember we're not returning anything when it increments and stuff. So we're going to do this, and we're going to do left is equal to left, guess what, times right. So you see the pattern where it's going left minus right for the increment, for decrement, minus for increment, left plus right for the multiplication thing. It's going to be times, and you see where this is going. So when we're going to be dividing, I guess you know the pattern where we're achieving. So our next function is basically going to multiply the x, y, z fields of an scn vector 3 with the same scalar function, scalar value I mean, and it's going to return the same result as an scn vector 3. So let's go ahead and create this function. This function is going to be multiply, and then we're going to name this vector as a type scn vector 3, and we're going to name a constant scalar, and this is going to be a type float, and it's going to return scn vector 3, open curly brackets. Okay, so now in here we're going to return scn vector 3 make x, y, and z. It's just going to be vector dot x times scalar, and then for y it's going to be vector dot y times scalar, and for z it's going to be, you guessed it already, vector times y dot scalar, and then for z, and for z it's vector dot z times scalar. Okay, now let's go ahead and create another function. As you can see, our errors are slowly starting to disappear. We've already started to create the classes, the other functions that are basically getting rid of all of these errors. So don't worry about them. I told you we're gonna get to the end of this together, and we're sticking through this. So now what we're gonna do, we're gonna create another function which is gonna multiply the x and y fields of an SCN vector 3 with the same scalar value, and this is going to be function times equals, so it's basically the incrementing but for multiplication, and we're going to take in the parameters of vector, and then it's going to in out, and it's going to be SCN vector 3 just as past. So you see the pattern that's going on, and we're going to go scalar, which is going to be a type float, and then we're not returning anything as I've mentioned before, and we're going to open curly brackets, and we're going to set vector, which is going to be equal to vector times scalar. Okay, and now we're going to create a new function which is going to be dividing. Now finally we reached to the divide section. It's going to be in the same exact pattern as we've already done, so you should be getting familiar with this. And this is going to be dividing two SCN vector 3s, SCN vector 3 vectors, and it's going to return the same result as a new SCN vector 3. Okay, so let's do this function divide, and it's going to take in the parameters left as SCN vector 3, right as SCN right as SCN vector 3, and it's going to return SCN vector 3. We're going to have open curly brackets, and then we're going to return right here SCN vector 3 make x, y, z. So it's going to be left dot x divided by right dot x. And we're going to do the exact same thing for all of them. So left dot y divided by right dot y. For z, it's going to be left dot z divided by right dot z. And then now we're going to divide the SCN vector 3 by each other. So what we're going to do here, oh, it's saying we're missing a parameter here. So let's see what we're doing. Oh, we're not missing anything. It's just Xcode being slow. We are in a beta, just remember that. By the time you guys are probably using this, you guys may not be on the beta, so some things may be changing, but don't worry. Xcode will suggest something and it should automatically fix by itself. So don't worry about that if some of your code may look different if you're watching this in the future. But now we're going to be dividing the SCN vector 3 by each other, and this is going to be like the increment thing but for division. So we're going to do function divide equals, and this is going to be taking the parameter left in out SCN vector 3, and it's going to take the parameter right as SCN vector 3, and we're going to have open curly brackets again, and we're not returning anything as I mentioned before, and we're going to do, you guessed it, left divided by right. Okay, so now that we've done that, now we're going to do the same thing that we did for the multiplication again. What we're going to do here is we're going to be dividing x, y, and z. We're going to be dividing the x, y, z fields of an SCN vector 3 by the same scalar value and return the result as a new SCN vector 3. So we're going to have the return function this time. So we're going to do function divide. We're going to take in the parameter vector as SCN vector 3 and scalar as a type float. And we're going to return SCN vector 3 as I mentioned. And we're going to have open curly brackets. And what we're going to do is we're going to be returning SCN vector 3 make. And x is going to be set to vector dot x divided by scalar, and then we're going to have vector dot y divided by scalar and vector dot z divided by scalar. And we're going to do the same exact thing, but this time we're going to divide the x, y, and z of an SCN vector 3 by the same scalar value, and we're not going to return anything. So we're going to have function divide equals vector in out SCN vector 3, and then scalar type float, and we're going to have open curly brackets, and inside this all we're going to do here is just set vector is equal to vector divided by scalar. Okay, so we're basically almost done now. We have a couple more functions to go. I think we have like, I don't know, but we have a few more functions to go. It's not that much. We're almost done. It's really simple. As you can see, our errors are going away, so everything is chilling now. We're getting ready for our future projects and stuff. This project, I'm just telling you right now, this extension is going to help so much in the future. We're just going to be linking towards this in and out, so we don't have to keep on writing this. So we're just writing this as one file right now, and we're going to get back to this later on. So okay, so now in our next thing, we're going to negate a vector basically. So now we're basically timesing it by -1. So we're going to name this function SCN vector 3 negate, and this is going to take in the parameters vector of type SCN vector 3, and it's going to have returning in SCN vector 3, and we're going to have open curly brackets, and inside these open curly brackets we're going to return vector times -1. And as you know, it's missing a function to return. Don't worry, we're returning it, the error will go away. And now what we're going to do is we're going to return the length, the magnitude of the vector described by the SCN vector 3. So let's name this function SCN vector 3 length And what this is going to do is going to take an underscore first, and we're going to name this thing, where it's going to take a parameter named a vector, and it's going to be of type SEN vector 3, and it's going to return a type float this time. So we'll open the curly brackets, and what we're going to do is return sqrt square root and then f, so it's a floating point. Okay, so now we have a float inside of here, and what we're going to do here is we're going to do vector.x times vector.x plus vector.y times vector.y, and then we're going to plus vector.z times vector.z. Okay, and now we're going to create another function called SEN vector 3D distance, and what this is going to do is basically return the distance between two SEN3 vectors. So let's go ahead and create this function. What did I name it? SEN vector 3D distance. SEN vector 3 distance. I believe that's what I started. And it's going to take in the parameters vector start, and it's going to be of type SEN vector 3. And it's going to take another parameter called vector end, and it's also going to be of type SEN vector 3, and it's going to return float, and we're going to have open curly brackets in here, and then we're going to return SEN vector 3 length this time, and the vector is going to be vector end minus vector start. Oops, not end, vector start. And okay, now we're going to create another function. Don't worry, we're almost done creating these functions. And this function is basically going to return the distance between two SEN3 vectors. This function is going to be called SEN vector 3 normalize. Let's go ahead and create this function, SEN vector 3 normalize. And it's going to take in the parameters vector, and the vector is going to be of type SEN vector 3, and then we're not going to take anything else, and we're just going to return SEN vector 3, and we're going to have an open curly bracket, and inside this we're just going to return vector divided by SEN vector 3 length, and the vector inside of here is just going to be vector, the thing that we just created in here, vector of type SEN vector 3. And now we're on to our almost last function. What we're going to do here is not our last function, but we're almost there. We're like really close to the end. We have like about 5 functions left. So now what we're going to do is we're going to calculate the dot product between two SEN3 vectors. So we're going to name this function SEN vector 3 dot product, and it's going to take underscore left as SEN vector 3 and also right as SEN vector 3, and we're going to return a type float in here, and we're going to open this up here, and inside of here what we're going to do is we're going to be returning SEN vector 3 make, and for x what we're going to do is left.y times right.z minus left.z times right.y, and then inside that we finished the x part, and now what we're going to do for y is left.z times right.x minus left.x times right.z, and then for z what we're going to do here, what we're going to do for z is left.x times right.y minus, minus left.y times right.x. Okay, so what we're going to be returning here is left.x times right.x plus left.y times right.y plus left.z times right.z. And okay, so we created that, and now we're going to create a new function which is going to basically calculate the cross product between the two SEN3 vectors. This is going to be called SEN vector 3 cross product, and this is going to take in the parameters left as SEN vector 3 and right as SEN vector 3, and it's going to return SEN vector 3, and we're going to open the curly brackets, and what we're going to do is return SEN vector 3 make, and I have this written out here. I've already done this, but let's go. What we're going to have for x is left.y times right.y minus left.z times right.y, and for y we're going to have, so we have separated by commas, so left.z times right.z minus left.x times right.z, and then we have a comma for z part. So the z part we have left.x times right.y minus left.y times right.x. And okay, so that's basically just calculating the cross product between the SEN vectors. Now we're going to make a new function that's going to calculate the SEN vector from lerping between two SEN vector 3 vectors. So this function is going to be called function SEN vector 3 lerp. And we're going to take in the parameters vector start of type SEN vector 3. And it's going to be type, we're going to take another one called vector end. And it's going to be type SEN vector 3. And we're going to take another thing called t, which is going to be a type float. And we're going to return an SEN vector 3. We're going to have open curly bracket. And then inside this function, it's going to be kind of lengthy. So we're going to have return SEN vector 3 make. So I already have this written out here again because it's lengthy. So we have vector.x plus vector start.x plus vector end.x minus vector start.x times t, comma. So we have to make sure you put the parentheses so you know which one you're doing first and then you're adding. So it's basically like telling parentheses first and then we're gonna do the rest of them. So it's gonna do this first, and then after that it's gonna multiply the whole thing, and then it's gonna add that. And then we're going to create the comma for the y parts of vector y, and we have the same vector start dot y plus vector end dot y minus vector start dot y times t. And then for z we have vector start dot z plus vector end dot z minus vector start dot z times t. And make sure you put the parentheses right here, so you want the minus to go first. So you want vector end minus vector start first, and then you want that to multiply by t, and then you want it to add to vector start. And okay, so now we're going to create a new function which is going to project the vector. It's going to be a vector to project onto the vector, so it's going to be a projection vector. That may sound a little confusing, so don't worry about that right now. We're going to get into it later on when we actually start creating our project. So this function can be called SEN vector 3 project, and this is going to take in the parameters vector to project, and it's going to be of type SEN vector 3, and it's also going to take in projection vector, and it's going to take in the project SEN. It's going to take in the parameter SEN vector 3. It's going to of type SEN vector 3. And it's going to return SEN vector 3. And we're going to have open curly brackets here. And okay, we're getting to the end of this. We're almost done. We have 2 more functions to create. And okay, so in here we're going to create 2 constants, which is one is going to be called scale, which is going to be of type float, and then we're going to have SEN vector 3 dot product. And for left we're going to have projection vector, and for right we're going to have vector to project. And what we're going to do with this is we're going to divide this by SEN vector 3 dot product, and we're going to divide it by left being projection vector, and then for right being projection vector again. So it's just being projection vector divided by projection vector, and then vector to project divided by projection vector. And then let's go ahead and create a new constant called v, and then this is going to be of type SEN vector 3, and this will be equal to projection vector times scale. Okay, we set this to type times scale, and what we're going to do here is we're going to return v, because this is going to be of type SEN vector 3, and that's what we want to return. Okay, so now we're approaching our last 2 functions, and both of these are basically, we're just converting angles into radians. So these should be really simple. We're going to create 2 functions, 2 last functions, and we're almost done. So let's go ahead and create this function called SEN vector 3 rotate, and it's going to take in the parameters vector of type SEN vector 3, and it's going to take in parameter around, which is going to be the type of SEN vector 3, and it's going to take in the parameters radians, which is going to be type float, and it's going to return SEN vector 3. And okay, we have the open curly brackets, and then let's go ahead and create our other function too while we're at it. So let's go ahead and name this SEN vector 3 project plane, and this is going to be of type vector. It's going to take the parameters vector, and it's going to be of type SEN vector 3, of course. And then we're going to have plane normal, which is going to be of type SEN vector 3, of course. And what we're going to do is we're going to return SEN vector 3 open curly brackets. And yes, we have errors because we haven't returned anything yet. So let's go ahead and create some constants in here. So let's name this constant RM, and this is going to be of type GLK matrix 3 make rotation, and then we're going to have radians X, Y, and Z. So radians, we're going to have radians, what we already have created, radians. Did I spell this wrong while I was creating it? I spelled it randians. It's radians. So now we have radians, and then for X, what we're going to have is around dot X. For Y, we're going to have around dot Y, and for Z, we're going to have around dot Z. And we're going to create another constant called V. Let V is equal to GLK matrix 3 multiply vector 3. And then here we're going to have matrix left is going to be RM, and then vector right is going to be SCN vector 3 to GLK vector 3, and the vector we're going to insert in here is just vector, and what we're going to be returning is return SCN vector 3 from GLK vector 3, and we're going to return V because we just created this. So okay, so we returned that, and now we're on to our final function. This is our last function for this whole extension, and what we're going to do is create one constant named projection, and this is going to be equal to SCN vector 3 project, and this is going to be taking the parameter vector to project, and it's going to be of type vector, and we're going to make another one called projection vector. What is going on? Plain normal. And we're going to have an open curly bracket. Oh, not open curly bracket. What am I doing? Sorry guys, it's 2 a.m. I'm sleepy. Okay. Now we're going to return our final thing, and we're going to return vector minus projection. And okay, and we spelled this wrong, vector to project. Okay, we should be good now. We'll just go command B. Build should succeed. And I'll see you guys in the next video where we use this extension, and everything is going to be so much easier. You'll be thanking us that we finished this earlier. So we're going to just call into functions from this, and we're going to be able to build so many things off this, like a brush tool. We're going to draw in AR world. We're going to build a line that's going to tag around everywhere. And yeah, so I hope to catch you guys in the next video. Peace. And for those YouTube guys watching right now, make sure to subscribe to my Udemy course right now. It's $30. It's not that much. I'm teaching you a lot about ARKit from the ground up, from the basics and everything. So if you guys enjoyed this, make sure you go maybe test it out. And yeah, see you guys there. Peace.